Okay, so get this. Microsoft uh, might have just cracked the code to like a whole new era of computing.
Oh, wow.
We're talking
Oh,
quantum computing, but not just any quantum computer.
right.
They've unveiled something called the Majorana 1 chip, and it's built on some seriously groundbreaking science.
Yeah.
We've got articles, blog posts, even a snazzy video they released,
Wow.
all pointing to some mind-blowing possibilities for like medicine materials, even cleaning up pollution.
Interesting.
So what makes this chip so different, and why should you care? Let's dive in.
Well, what's fascinating here is that Microsoft isn't just building another quantum computer.
Right.
They're creating an entirely new path to solving problems that were previously impossible.
Right, and a lot of the excitement boils down to this Nature article
Uh-huh.
about a successful experiment with a new kind of qubit.
Okay.
You know, qubits are like the bits in a normal computer,
Yeah.
but way cooler
Right.
because they can be in multiple states at once.
Yeah.
But this one is different.
Okay.
This qubit uses something called a Majorana particle.
For decades, these particles were purely theoretical.
Mm-hmm.
Physicists knew they should exist but could never quite prove it.
Right.
Now, not only has Microsoft observed them,
Wow.
they've figured out how to control them.
Amazing.
And that's huge because a Majorana particle
Yeah.
is this bizarre entity
Okay.
that's its own antiparticle, meaning it's a particle that's also its own opposite.
Okay. My brain is already doing backflips.
Oh.
But how do you actually compute with a particle that's its own nemesis?
It all comes down to something called parity.
Right.
Think of it like this. You've got a system,
Yeah.
and it either has an even or odd number of electrons.
Okay.
That's the basic information these qubits store,
Uh-huh.
even or odd instead of the usual 0 or 1.
So it's like a secret code
Right.
hidden in whether there's an even or odd number of electrons.
Exactly.
And Microsoft can actually read this code.
They've found an incredibly clever way to do it. Imagine tiny semiconductors
Okay.
called quantum dots that can hold electrical charge. They're linked to a nanowire, which is where these Majorana particles hang out.
Okay.
By using microwaves to measure the charge on the quantum dot,
Yeah.
they figure out the parity of the nanowire, and bam,
Wow.
they know the state of the qubit.
That's some next level stuff.
Yeah.
And I'm guessing this has something to do with why these Majorana qubits are so stable.
Yeah.
I mean, one of the big hurdles with quantum computers is how sensitive they are to, well, pretty much everything.
You're spot on. Encoding information in this parity state
Yeah.
makes these qubits remarkably resistant to noise and errors. Think about the implications.
Yeah.
Fewer errors mean faster processing, and get this.
What?
They believe they can fit 1 million qubits onto a single chip the size of your hand.
1 million. I can't even imagine the kind of problems you could solve with that much quantum firepower.
Exactly. And that's where it gets really exciting. If we look at the information in their blog posts and video,
Right.
Microsoft outlines some pretty mind-blowing potential.
Okay.
We're talking about designing new materials with unheard of properties.
Like self-healing bridges and phone screens that magically fix themselves.
Precisely. Imagine materials that can adapt to their environment or repair themselves when damaged,
Right.
and that's just the tip of the iceberg.
Wow.
They're also talking about developing catalysts to break down those pesky microplastics clogging up our oceans,
Okay.
and creating super efficient enzymes for medicine and agriculture.
So we could potentially be looking at solutions to some of the biggest challenges facing humanity.
Yeah,
Pollution, disease, maybe even world hunger.
absolutely.
This feels like something straight out of a sci-fi movie.
It might sound like science fiction, but it's all rooted in the very real limitations of our current computers. Even the most powerful supercomputers
Right.
struggle to accurately model complex quantum systems.
Oh, wow.
1 million qubit machine could change everything. We could understand and design materials and molecules from the ground up with incredible precision.
No more trial and error, just pure scientific design from the get-go.
Exactly.
That's a game changer for just about any industry you can think of.
Imagine being able to tell an AI, hey, I need a material that's super strong, but also lightweight and flexible.
Yeah.
And it spits out the perfect recipe based on quantum simulations.
Okay.
We're talking about a world where we can design solutions to problems before they even arise.
Okay, I'm officially mind blown.
Yeah.
But we've only just scratched the surface.
Right.
This topological superconductivity they're talking about, that's a whole other rabbit hole of fascinating science.
Definitely.
And what about the actual architecture of this 1 million qubit beast?
Yeah.
There's still so much to unpack here.
You're right, we've just started our deep dive. Let's take a closer look at the science behind these Majorana particles
Yep.
and how they're harnessing them to build this groundbreaking quantum computer.
Yeah, that sounds awesome.
It is pretty cool. You know what's truly remarkable about this whole story? It's not just the science itself, but the journey Microsoft has taken to get here.
Yeah, totally. This isn't some overnight success story.
Yeah.
They've been laser focused on this for years.
They've been laying the groundwork for almost 2 decades, going all the way back to the early 2000s, when they established their Station Q research lab dedicated entirely to exploring topological quantum computing.
Talk about commitment. They've poured resources into this idea, even when it was considered fringe science. For the longest time, Majorana particles were purely theoretical, a physicist's daydream.
Many people in the field doubted they even existed, let alone that they could be harnessed for building a quantum computer. But Microsoft saw the potential and they just kept pushing, kept researching, kept believing.
And now they've not only proven these elusive particles are real,
Right.
but they've figured out how to actually build a quantum computer chip using them. I mean, that's a level of dedication you don't see every day.
It's a real testament to their long-term vision and to the power of scientific curiosity. And let's not forget the sheer engineering brilliance it took to make this happen. They knew from the start that to build a truly scalable quantum computer, they needed a completely new approach.
Right. The traditional qubit designs with their complexity and susceptibility to errors just wouldn't cut it if they wanted to hit that million qubit goal.
Exactly. Those designs are like trying to build a skyscraper with toothpicks. You need a stronger foundation, something radically different. And that's where the topological codec comes in.
Okay. So we know they've got this unique building block,
Yeah.
the tetron, but how do they actually connect these tetrons to create a larger, more powerful system?
Right.
It's like building with quantum Legos, right?
Yeah, it's a great analogy. And you're right, it all comes down to how they're connected. Remember those perpendicular superconducting wires we talked about?
Yeah.
They act as couplers between adjacent tetrons, creating pathways for quantum information to flow through the system.
So it's like creating a quantum circuit.
Right.
With the tetrons as the logic gates and these couplers as the wires connecting everything together. I'm starting to get a picture of how this whole architecture comes together.
And here's where their measurement-based approach to quantum computing really shines when it comes to scaling up. Think about it. With traditional qubit designs, you'd have to individually control each qubit, sending complex signals to each one.
Which would be an absolute nightmare with a million qubits. Talk about information overload.
It would be practically impossible to manage. But Microsoft's approach is different. They use global control signals that influence all the qubits simultaneously.
Oh, wow.
Like a conductor leading a massive quantum orchestra.
It's an elegant solution.
Yeah.
And this global control is what allows them to cram so many qubits onto a single chip.
Right.
They don't need all that complex wiring and control circuitry for individually addressed qubits.
Precisely. And because their qubits are so stable and their error correction so efficient, they don't need to worry as much about packing them super tightly. They found a sweet spot between density and stability, essential for scalability.
This is what sets them apart. They're not building a quantum computer just to solve today's problems. They're building a platform for the future, something that can tackle problems we haven't even thought of yet.
It really does feel like we're witnessing the birth of a quantum internet,
Yeah.
where interconnected quantum computers can collaborate on an entirely new scale.
Okay, now you're getting me really excited. But let's take it one step at a time. Before we start building quantum cities in the metaverse, we need to understand the real-world applications of this technology.
You're right. Let's focus on the near-term opportunities. And believe me, there are plenty. We've touched on some of them: designing new materials, revolutionizing drug discovery, tackling climate change.
But I'm hungry for specifics.
Yeah.
Give me some concrete examples of how this tech could change the world.
All right, let's start with material science. Right now, we're basically throwing darts in the dark when it comes to discovering new materials. It's a lot of trial and error, very time-consuming, and often yields disappointing results.
How do Majorana particles change that?
With quantum computing, we can simulate the behavior of materials at the atomic level. Imagine being able to design a catalyst that speeds up chemical reactions, making manufacturing processes more efficient and sustainable.
Or discovering a material that's superconducting at room temperature,
Yeah.
completely revolutionizing our energy grid.
Exactly. We could create super strong but ultra lightweight composites for building everything from cars and planes to skyscrapers. We could even design materials that can repair themselves, making our infrastructure more resilient.
It sounds like a material scientist's dream come true.
Oh.
And I know you mentioned drug discovery earlier. Tell
Yeah.
me more about how quantum computing can help us conquer diseases.
Drug discovery is another area ripe for disruption. Currently, it takes years and billions of dollars to bring a new drug to market. It's a laborious process of screening millions of molecules looking for potential candidates.
But with quantum computers, we could simulate the interactions between drugs and biological systems with incredible accuracy.
Precisely. We could identify promising drug candidates much faster, saving time and money. And think about personalized medicine.
Yeah.
Designing drugs tailored to a specific patient's genetic makeup?
So we could potentially develop treatments for diseases like cancer, Alzheimer's, and HIV that are more effective and have fewer side effects. That's a game changer for millions of people around the world.
Absolutely. And the applications go far beyond just materials, science, and drug discovery. Think about finance. Quantum computers could revolutionize risk management, portfolio optimization, even fraud detection.
So helping Wall Street make even more money.
That's one way to look at it. But it could also level the playing field, giving smaller investors access to sophisticated financial tools. And don't forget about logistics. We could optimize supply chains, route delivery vehicles more efficiently, and even create smarter traffic management systems.
Okay, less traffic and faster deliveries. Now you're speaking my language. But I can't let you go without talking about artificial intelligence. How does quantum computing impact the future of AI?
That's a big one. Quantum computers could lead to entirely new machine learning algorithms, ones that are vastly more powerful than anything we have today. Imagine AI that can learn faster, adapt to new situations more easily, and tackle problems that are currently impossible for even the most advanced AI systems.
So we're talking about AI that can not only beat us at chess, but compose symphonies, write novels, and maybe even crack the code of consciousness itself.
Those are some bold predictions, but it's certainly possible quantum computing could unlock a whole new level of intelligence, one that could fundamentally change our understanding of what it means to be human.
Okay, this is getting pretty deep.
Yeah.
I'm starting to see how this technology has the potential to touch just about every aspect of our lives.
And we've only just scratched the surface, but before we get carried away with dreams of a quantum-powered utopia, it's important to be realistic. There are still many challenges to overcome before this technology can truly reach its full potential.
Right, this isn't all sunshine and roses. What are some of the hurdles standing between us and this quantum future?
One of the biggest is qubit coherence.
Okay.
Keeping those qubits in their delicate quantum states long enough to do meaningful calculations. It's like trying to balance a spinning plate on a stick. The slightest disturbance can knock it off.
And error correction is another big one?
Absolutely. Quantum computers are incredibly sensitive to noise and errors, so we need robust ways to detect and correct those errors.
It sounds like there's still a lot of work to do before we're all walking around with quantum smartphones in our pockets. But with companies like Microsoft investing so heavily in this technology, I have to believe we're headed in the right direction.
I agree. The progress that's been made in the last few years is astonishing, and it feels like we're on the cusp of something truly groundbreaking. But before we go any further, let's take a step back and consider some of the bigger questions surrounding this technology.
Good point. We can't just blindly charge into the quantum future without thinking about the implications. What are some of the ethical considerations we need to address as this technology evolves?
Yeah, it really is a bit mind-boggling, isn't it? We've been talking about building bridges and curing diseases.
But the implications of quantum computing go so much deeper. It's like we're standing on the edge of a whole new way of thinking about computation itself.
It is a paradigm shift. For centuries, we've been bound by the limits of classical physics, forced to break down complex problems into smaller, digestible pieces. Even then, there were questions we simply couldn't answer, calculations we couldn't make.
It's like we've been trying to solve the universe's biggest puzzles with a child's set of building blocks.
But quantum computing
Right.
throws open the doors to a whole new toolbox, a way to explore the strange and counterintuitive world of quantum mechanics.
And with that comes a whole new level of responsibility.
Right.
This isn't just about faster algorithms or more efficient simulations. We need to seriously consider the ethical implications of having this kind of computational power at our fingertips.
It's like we're holding the keys to a brand new car. Powerful, sleek, and capable of incredible speed.
Yeah.
But we need to learn how to drive it responsibly before we hit the gas.
Exactly.
Otherwise, we risk veering off the road completely. Any technology this powerful can be used for good or for bad. We need to be thinking about guidelines, regulations, ways to ensure that quantum computing benefits humanity and doesn't become a tool for harm.
And this isn't something that scientists and engineers can figure out on their own. We need a public conversation, a dialogue that involves everyone to shape how this technology evolves and what its role in our society will be.
It's a question of values, of priorities, of the kind of future we want to build. Do we focus on applications that address climate change, improve healthcare, and uplift communities? Or do we allow this technology to exacerbate existing inequalities and concentrate power in the hands of a few?
Those are some tough questions, and there aren't any easy answers. But they're questions we can't afford to ignore.
Absolutely. As we enter this new era of quantum computing, we need to proceed with both excitement and caution. We need to embrace the incredible potential while being mindful of the risks.
It's about finding that delicate balance between pushing the boundaries of what's possible and ensuring that those possibilities are used to create a better world for everyone.
And it's a journey that will require collaboration, open dialogue, and a willingness to ask tough questions.
Well said. And speaking of tough questions, I think it's time to turn the microphone over to our listeners.
Mm-hmm.
We've laid out the potential of quantum computing, the challenges, the ethical considerations, but now we want to hear from you.
If you had access to a million-qubit quantum computer, what world-changing problem would you tackle? What possibilities would you explore? What future would you build?
That's something for you to ponder as we wrap up this deep dive. We've only scratched the surface of what's possible with quantum computing. It's a field that's evolving at breakneck speed.
So stay curious, stay engaged, and most importantly, keep asking questions.
Yeah.
The quantum revolution is just beginning, and we're all in this together.
And on that note, we'll sign off for today. Thanks for joining us on this incredible journey into the world of Majorana particles and quantum computing. Until next time, keep diving deep.